Example 3.3. The table here describes the distribution of a random sample S of 100 individuals, organized by gender and whether they are right or left-handed. So in the example, we need to find a few probabilities. The first probability that we need to find is the probability of male in this sample. So the M denoted male. Okay, so what it means is all the people in this sample, how many of them are male? So we look at the table, we just need to add up how many male are there. So it is 43 plus 9 divided by 100. Okay, so you use a calculator, is 0.52. And you can also write it on the sidebar. Okay, 43 plus 9 is 52 male. And then you can also add up the female, right? That is 48 female. And these two numbers should add up to be 100. So now the next question is find the probability of female out of this sample. Again, you do 44 plus 4 divided by 100. All you can do is the probability of male is 0.52. And they should all add up to 1. So you know the female should be 0.48. Because in the population, in this example, the individual are either male or female. Therefore, they should add up to 1. That's a way to verify your answer. Now, the next question is find the probability of right-handed. The subject is right-handed. Okay, so we just look at the table and see, okay, how many people are right-handed? So 43 male are right-handed and 44 female are right-handed divided by 100. Okay, so you add up those number is 87 and you use a calculator. 87 divided by 100 is 0.87. Now, in order to find the probability of left-handed, there's two ways. Okay, you can add up the left-handed people. So in this case, we have 87 people are right-handed, and 9 plus 4 is 13 people are left-handed. We can either do it that way, okay, add up, or we can think of it as they have to add up to 1. So you do 1 subtract 0.87. You will get 0.13. So this is just a little bit different than what we have been doing, just showing you there's a different way to calculate this probability. The next question is to find the probability that a subject is a male and is right-handed. So you see there's an and, okay? What you usually would do is telling you is in one of the shell in the table. Okay, so you locate that shell. Male is right here and right-handed is right here. So that is the location of the shell, and it is 43 of them. And altogether we have 100 people. So the probability is 0.43. And again, you need to remember all probability are decimals. Okay, it's between 0 and 1 inclusive. So that is a way to double check that your answer is correct. The next probability is to find that probability that the subject is a female and is left-handed. So again, you locate female and left-handed. You should see it's only 4 of them and divided by 100. Make sure you use a calculator and write it correctly. Okay, it's 0.04. That's a probability. Now the next probability, okay, find the probability of male all female. Okay, so again, in this table, particular table, we only have male and female. Okay, so that is the entire population. So you have to add up all the male numbers. So it's 43 plus 9. All, right? All, the word all tell us to also add. For the female is 44 plus 4. Okay, then all over 100. And you should you can use a calculator to verify that. The answer is 1. Now that's another way to do it. Okay, is you find the probability of male, which is 0.52, or tell you to add the probability of female, which is 0.48. So that add up to be 1 also. So next, you find the probability of male or right-handed. Okay, now this is important to see the difference. Okay, so you want to find a male. Okay, we can count. Okay, 43 plus 9 are the male, and then it says all right-handed. So again, you add. Okay, so which right-handed we have not add yet? 43 is already added. We don't want to add it again. But then 44 is not added. Okay, it is right-handed and it's not added yet. And then you divide it by 100. So basically, male is right here. All right-handed, you're talking about this region. Okay, so then you add up the number. Use a calculator. 43 plus 9 is 52, and 52 plus 44 is 96. So it's 0.96. This is how we get that answer. Next, find the probability of female or left-handed. So using the same approach, okay, we have how many female? We have to add it up. 44 plus 4 female. Okay, all, right? So add. How many of them are left-handed? And we have not counted. So we count 44. We count 4. And it's also all left-handed. So we didn't count the 9 yet. So we put the 9 there. And then divide it by 100. Again, use a calculator. Okay, it's 48 plus 9 is 57 divided by 100, so 0.57. And then find the probability of male, but then pay attention. There's a prime on the top. What it means is the probability that a person is not male. Okay, that is the same as saying, well, because we only have male or female right here, so it's the same as saying as find the probability of female. Okay, and in this case is we already know the answer is 0.48 from earlier. And then the next few will be a little bit not as intuitive. So find a probability. So maybe I use a different color. So these are a little bit involved. Find a probability of right-handed given male. So what does this mean? It means out of, so this means out of all the males, what proportion or what's the probability that they are right-handed? Okay, so whenever you see this, okay, this part means given. You can think of it as a division line. And what is on the top is the R, and what is in the bottom is the M. You left to right, top to bottom. Okay. Now we need to find out how many males are there. It's 52 males. Okay, it's right here, 52 males. Out of the 52 males, how many of them are right-handed? Okay, so 43 of them are right-handed. So now, then you use a calculator. 43 divided by 52. And you round your answer according to the instruction. Okay, so you round to 4 decimal is 0.826923 and so on. Okay, you need to round to 4 decimal. 1, 2, 3, 4. Okay, you look at the digit right next to the 9. If it's a 5, 6, 7, 8, 9, you add 1 to the 9 and so on. Okay, so you add to the 9. But if it's 2, 4 and below, then we just get rid of the rest. So then the answer is just 0.8269. So I'm going to erase it. Okay. Now the next example is find the probability of female given that the person is left-handed. Again, that this line is telling us to draw a line, division line, and the top should be female, but the bottom should be left-handed. And you always go from the bottom first. Okay, so how many people are left-handed? Well, we take a look. 9 plus 4. Okay, 13 of them are left-handed. And how many out of the 13 are female? 4 of them. Okay, so you do 4 divided by 13 in your calculator. Then again, you need to round. Okay, so it's approximately 0. So I'm going to write out the whole thing I see in the calculator. Okay, we want to round to 4 decimal. So in that case, because it's 4 decimal places, right next to the 6 is a 9. You need to add 1 to the 6. Okay, so now you round it. It's 0.3077. But if you just writing it down, you don't have to. You can skip the step that write out the entire thing that you see in the calculator. All you need to write down is 0.3077. Now the last probability that we need to calculate, similar. Okay, it's left-handed people given that it's a female. Then some students sometimes might get confused. Oh, should I just flip the probability earlier? Should it be 13 over 4? That is not correct. Okay, this is not just simply a fraction. And again, you can check 13 over 4 is a number that is bigger than 1. And the probability should never be bigger than 1. So that is a signal that that is not the right answer. So again, we follow our procedure. Okay, given that is female, so we draw a division line. And first, we figure out the denominator. Okay, how many people are female? Well, take a look at the table. 44 plus 4, so 48 of them are female. Now, out of the 48 people, how many of them are left-handed? 4 of them. And then you enter the fraction into your calculator. 4 divided by 48. And you do the rounding. Okay, so you can write down as 0.083. The next one is 3. Okay, but right next to the 3 is also 3. So you just truncate it. And that is the final solution.